Hello friends, now we see the derivative of exponential function with proof. The second topic is fx is equal to a raised x. Now let's see the proof. First of all, we start with f of x is equal to a raised x. Therefore, f of x plus h is equal to a raised x plus h. And that can be written as by using indices rule a raised x into a raised h. Since a raised m plus n can be written as a raised m into a raised n. Then by first principle of derivatives, f dash x is equal to limit h tends to 0 f of x plus h minus fx whole thing divided by h is equal to limit h tends to 0. For f of x plus h, we substitute a raised x into a raised h minus for fx we substitute a raised x and then whole thing divided by h. So is equal to, now in the next step we take a raised x common from numerator. So we have limit h tends to 0 a raised x in bracket a raised h minus 1 whole thing divided by h. Now since here limit depending on h, so according to that limit a raised x term must be constant, so we take outside the limit. So the next step will be a raised x into limit h tends to 0 a raised h minus 1 whole thing divided by h is equal to, now a raised x into, now limit h tends to 0 a raised h minus 1 upon h. So by using limit formula, this gives answer log a. So therefore f dash x is equal to a raised x into log a. So in this way we proved derivative of a raised x as a raised x into log a. Thank you.